Hello everyone. So I just wanted to verbally tell you about these definitions of absolute max and absolute min and relative max and relative min. And so it's not necessary that you do watch this video, but I figured it might be helpful for some of you just trying to verbally digest what's going on as far as these definitions before you dive into this example. Okay, so a function f has an absolute min at c if f of c is less than or equal to f of x for all x in the domain of f. And then for absolute max, it's very similar to absolute min, except we just change the inequality sign, right? So we have a function f has an absolute max at x equals c, or point c, if f of c is greater than or equal to f of x for all x in the domain of f. All right, and so what might be helpful is what I have in red here, just putting it in different wording, because what's in the box is very formal, technical, mathematical definition. Okay, so in red here I have, in other words, f has an absolute minimum at x equals c if f of c is the lowest point on the graph of f. Okay, so visually you can get your head more wrapped around that if you were looking at a graph and just saying, here, look at this graph. What's our absolute minimum? Well, it's just the lowest point on the graph of f, okay? And then as far as looking for the absolute maximum on our graph at x equals c, we would say that it's an absolute max at x equals c if f of c is the highest point on the graph of f. So just look graphically at your function and try to find the highest point, and whatever that highest point is, that's going to be your absolute maximum. Okay, and so what's the difference between the absolute max and absolute min versus the local max and local min, or in other words, relative max and relative min? Well, the main difference between the relative extrema and the absolute extrema is the relative extrema is just looking at all x values in the vicinity of c, whereas for absolute extrema, it's looking at for all x values in the domain of the function. Okay, so here I have these, technical definitions for relative min and relative max, and you'll notice that that's the only difference between relative and absolute, is at the end, after the inequalities and such, it says for all x in the vicinity of c instead of for all x in the domain of f. All right, so now looking at what I have in red, this will help you more visually get an idea of what this actually means. And so what I'm saying to you is to find the relative or local max. The reason why I'm interchangeably using those words is because they mean the same thing, relative max and local max. It just depends on, how it's worded to you in a problem or a textbook or whatever. But the definitions are the same. The words mean the same thing. Okay, so informally, to find the relative or local max, you look visually for the peak part of a mountain shape looking thing. All right, and so what I mean by a mountain shape here, mountain shape, I'm talking about something that looks like this. Okay, and so the peak, whatever's at the top, that would give you your local max. And then for your relative or local min, you want to look for the bottom of your valley. All right, so in other words, look for something that looks like this. Okay, and so you don't just want to look only for, peaks of a mountain shape or the bottom of a valley shape. You want to also look at the endpoints for a local extrema, all right, because your endpoints are also local or relative extrema. You just have to identify whether or not it's a local max or a local min. Okay, so when we actually do examples, you'll see more of what I'm talking about as far as endpoints, because in particular, I'm doing more of examples of functions over an interval where there are endpoints, right? But if you were looking at a function on the real numbers, then you wouldn't have any endpoints, and so you wouldn't have to worry about whether or not those endpoints, are they a local max or local min, like what's going on with that. But anyways, So tune in for the next video to get an explanation for how to do the first example.